Okay, so we've seen a few of these problems, but we haven't really talked about how to solve these quadratic equations when it's not a 1 AM trinomial, or when it's not a slip and slide, or when it's not a difference of squares, such as problem number 25. 25 says 2z squared plus 20z. Notice this is not a trinomial. There's only two terms, and it's not the difference of squares. So the only thing left that I could see, and what I need to check for first always, is a GCF. And the biggest thing that divides into both of these would be a 2 and also a z. So I'm going to factor out a 2z from that polynomial. So when I divide this by 2z squared divided by 2z is just z, and 20z divided by 2z is just 10. And now I have the GCF factored out. So this is why this problem looks different, is because there's not two sets of parentheses. But just think of it like the GCF. You could put it in parentheses. So think of it like that. So you're still going to take each factor and set them equal to 0. So you set 2z equals to 0. And then when you divide by 2, you get z is equal to 0. And you also take the other one, z plus 10, and you set that equal to 0. So when you take away 10, you get z equals negative 10, and there's your two solutions. So it still worked the same way. You're just factoring it a different way. You're using the GCF. So a question like 26, 8p squared minus 4p equals 0. So the GCF here would be 4p. So I'm going to factor out a 4p. Remember, the process was divide everything by 4p. So 8p squared divided by 4p would leave me with just 2p. And 4p divided by 4p would be a 1. So then I'm going to take each factor, take the GCF, and set it equal to 0, which means p is going to be 0, because when you divide both sides by 4. Then you take the 2p minus 1 and set that equal to 0. Add 1 to both sides, and you get 2p equals 1. I'm not finished yet. I need to divide by 2, so you get p is equal to 1 over 2. So your two solutions were p equals 0 and p equals 1/2. Now remember, if one side is not equal to 0, you have to make it equal 0. So when I take away 27x here, that's going to leave me with 9x squared minus 27x equals 0. And this is not the difference of squares. This is a perfect square, but this one's not. So I need to look for a GCF. The GCF here would be 9. 9 divides into both of those, and also an x. So I'm going to factor out a 9x. So 9x squared divided by 9x is just x, and negative 27x divided by 9x is negative 3 equals 0. Set each one of these equal to 0. Take the 9x, set that equal to 0, which means x is going to equal 0. Take the x minus 3 and set that equal to 0, which means x is going to be equal to 3. And there's your two solutions, 0 and 3. Now you're going to see problems on the work that look like number 19. If you notice, there's a parentheses. This guy here is already factored. So they've done the hard work for you. All you have to do on a problem, if it's presented to you this way, is just take the GCF and set it equal to 0, which there's one of your solutions already. Take the other factor, x minus 32, and set that equal to 0, which means x is going to equal 32. So your two solutions are 32 and 0. On a problem like this, and a problem like 20, and a problem like 21, everything's already factored for you. They've done the hard part, and what gives it away is you see something multiplied times something else. This is 4b times b plus 4. So you just set each factor equal to 0 and solve it. Same with 21, same with 24. You just see it. There's two sets of parentheses. It's already factored for you. So if it's already factored for you, you just set them equal to 0, set each factor equal to 0, and then solve it. And if it's not factored for you, then you have to factor it, and that's what we were doing here. Last one, 28. it's not factored. I don't see things being multiplied together. I don't see those parentheses. And this side doesn't equal 0. So I'm going to need to minus 15x from both sides. And minus 15x here. So that leaves me with 18x squared minus 15x equals 0. And now it equals 0. So now I can look for a GCF. I'm going to turn the page over. 18x squared minus 15x equals 0. And I'm going to go from there. So the GCF, what divides into 15 and 18, the biggest number would be 3. And they also have an x in common. And remember, it's the smaller of the two. I'm going to divide both sides by 3x. This leaves me with 6x minus 15 divided by 3 is 5, and the x's cancel. So we're just factoring using the GCF. We've got two things now being multiplied together. Think of it like that's in parentheses. Set that equal to 0. Set your 6x minus 5 equal to 0. When you divide by 3, 0 divided by 3 is 0. You add 5 to both sides. You get 6x equals 5. I'm not finished. This is a two-step equation. Divide by 6. And you get x equals 5 over 6. And there's your two solutions. Factoring and solving using the GCF.